Well, howdy there, Internet students. It's Mr. Hermanson again. Hey, today we are going to start combinations and probability problems. To me, this is some really interesting math and really just something that everybody uses in real life, whether you know it or not. Um, so almost everything that happens to you happens based on some probability. Um, and there is a way to figure out some of that. So we're going to talk about that today. So probability is like the chance that something will happen. Like what is the chance it will rain today? And as I'm looking out the window, I'm going to say there's a 0% probability of rain today. But you never know what can happen later on. An event is a specific outcome, and when I'm talking about rain, it either will rain or it won't rain. Some would say, well, it could snow or whatever, but precipitation or no precipitation. Okay, so let's do a little problem here. Let's suppose that there are 10 marbles in a bag. Let me get my highlighter here so you can follow along. And 6 are blue and 4 are purple. If you draw out one marble at random, what color is it most likely to be? I hope you pick blue because there are more blue than purple. Okay, but you doesn't mean you will get a blue, but you're just more likely to get a blue. Okay, and we can put a number on that. The chances that the marble you draw will be purple are 4 out of 10. What are the chances the marble will be blue? I hope you were thinking 6 out of 10. Now you can also say, since that's a fraction, you could simplify that to 3 out of 5, or we can call that a ratio too. Suppose you draw a marble and put it in your pocket. Then you pick out another marble. What are the chances it will also be blue? So you pick a blue marble, you put it in your pocket, and then you draw a second marble. Okay. Now, notice that in this situation, the total possibility changes to 9 because you're missing one blue marble. And since you know the one in your pocket is blue, that means there's only 5 blue left. So we would say the probability is now 5 out of 9. Now, you can write a probability as a ratio, like we did in the last one, 5 out of 9. But remember, ratios can also be written in other ways. You could write you could actually write it as a ratio a couple of ways. You could do 5 to 9 using the word 2. You could use these little colon marks also, or you can write it as a fraction. Those are all considered ratios. The decimal, you would have to divide it out, and if you do that, you would get 0.5 repeating. And if you change that to a percent, you would see that's 55.5 repeating percent. So those are all ways you could do that. All right, so a bag holds 6 blocks. They're numbered 1 to 6. Imagine drawing one block from the bag. Okay, go ahead and fill in the first 4 answers here. All right, how'd you do on those? Just explain on this one. Here's how I explained it. I just drew a little diagram over here. I circled all the ones that were odd, the 1, the 3, and the 5, and that is 3 out of all of them, which is 6. So there's my work right there. All right, suppose a friend tells you she drew a 2, a 3, or a 5. What is the probability that she drew an odd number that is not divisible by 2? Now, we definitely know that she drew one of these 3 numbers. So those are our choices. It's either a 2, a 3, or a 5. So what do you think the probability that she'll get an odd? I think it's 2 out of 3 because you know it's one of these 3, and out of those there's 2 odds, the 3 and the 5. All right, suppose you take a block from the bag of 6 blocks and record its number. Then you return the block to the bag, mix up the blocks, and draw another. What is the probability the number on the second block is 2? Now remember, we put all of them back in. So there are 6 numbers in there to choose from. So the second block is a 2. There's one way to get a 2 block out of those 6 blocks that are in there. So it's really the same as on the first draw, getting a 2. We call those independent events. What is the probability the second number is odd? It's going to be the same as what we did up here, where we saw that, which one was that? Oh, here it is. Where there's still 6 in there, 3 of them are odd, so 3 out of 6. Now, just a reminder, you could also say 50% on that. You know, there's different ways you can represent probability. All right, in the next situation, we are going to take 6 number cubes, number 1 through 6, put them in a bag. The first block we draw will be recorded and then returned to the bag before drawing again. And then we're going to draw out a second one. So we're going to get 2 blocks. But remember, we put it back in, so we have the choice of that same block twice. So we're going to use this table to help us list the possible ways. So you're going to put the first block is the first number I wrote, and it comes from this side here. So this first block is 2, and the second block is 1. This first block is 3, the second block is 1. This first block is 1 coming from here. Second block is 2 coming from here. And so on. Go ahead and fill in the rest of that chart because we're going to use it to do some problem. All right. How many possible outcomes are there? Everything on this chart is a possible outcome. So I could pick any one of these and that could happen. Like this could happen. I could get 5 on the first draw, 5 on the second draw. Okay, and so there are 6 times 6 possible outcomes, which is 36. How many possibilities exist in which both blocks are odd? Okay, so to figure this out, count how many are like this, where the first number and the second number are both odd. Go ahead and do that and write that down. All right, you should have counted 9 of them. I circled all of them where they're both odd. And that's 9 out of 36. We can simplify that fraction. That's 1/4. So 1/4 of the time you're going to get both odds. What is the probability you will draw 2 odd numbers? We already answered that. Sorry, this one, this answer above here goes down here. And we were just supposed to answer 9 here. Okay. What is the probability you would draw the same number twice? Look for those on the chart and write down your probability. See if you get it. You should have said 1/6 for that one. Okay, now we're going to do something a little different. Imagine taking a block from the bag, putting it in your pocket, and then drawing a second block. So whatever one you draw the first time is not available for your second draw. What is the probability the first number is odd? Well, there's 6 different blocks, remember, and there's 3 odd ones in there. So that's just 3 out of 6, or half, or 50%. Okay, now you will find the probability the second number is odd. So we list all the possible ways you could have drawn 2 blocks. And notice that we crossed some out. Think about why we did that. So I hope you were thinking that it's because we didn't replace the first one. So you can't get the same number twice because you got one in your pocket. Okay, so count up the possibilities. Well, there are 36 minus those 6 that we crossed out. So there's 30. What is the number of possibilities that have an odd second number? That would be 15. That would be all these that have a 1, all these that have a 3, all these that have a 5 as the second number. Okay, what is the probability that you will draw an odd number the second time? Well, that's going to be 15 out of the 30 total possibilities, or 1/2. Compare the probability you found in problem 9 to that you found in 10D. Okay, so in 10D on the last one, or on problem number 9, the probability we got that the first number was odd was 1/2. And the probability the second one was odd is also 1/2. So they're the same. So now what is the probability both numbers would be odd? Think about that for a second. Now I thought it would be easier just to circle all those on the chart to help me out with that, and I noticed there were 6 of them where they're both odd. And that's out of 30, which simplifies to 1/5 or 20%. In 8D, that's on the previous page, we found that the probability you would draw 2 odds if you did replace the number was 1/4. And in this one, we found that the probability that both would be odd if you didn't replace, if you kept it in your pocket, is 1/5. So the reason why is because we kept a tile. We didn't replace. So what happened the second time kind of depended on what happened the first time. All right, when an object is drawn out and not put back, it is called probability without replacement. It can also be called dependent probability, since the second event is dependent on the first event. All right, now suppose that before you choose a second block, you look at the number on the first block. If the first number is odd, what is the probability the second number will also be odd? Remember, you know that your first number is definitely odd. So circle all the things that have the first number odd to start here. So that would be those. Go ahead, you finish. Now, after I circled all them, I'm going to take a blue one, and so we know the first number is odd. Now, the second number being odd, let's find all those that where the second number is also odd, like this one, and I'll circle those in blue. You're not going to circle one like this because that's 2. The second number isn't even, so go ahead and circle all those. And you should notice that there's 6 blue ones out of the total that we circled, which was 15. Now that can be simplified by dividing both the numerator and denominator by 3, and that makes 2/5. If the first number is even, what is the probability that the second number will be odd? So for this one, we want to circle all the ones where the first number is even. Go ahead and do that. So you should have circled 15 of them. Now, of those, we want to find the ones where the second number is odd. I'll change to red for that. The second number is odd. It's a 1. Go ahead and do that. And that gave me 9 red circled out of 15 total. Suppose you draw one block from the bag of 6, and then without putting it back, draw another. What is the probability of drawing the same number twice? Think about that. Write down an answer. See if you get it. You should have said 0, because since that number isn't there, you can't draw it. Remember in 8E we found the probability of drawing doubles with replacement. Why is the answer different from the answer to 8E? Because you do not have that number as a choice anymore. All right, I think we're good here. You can go ahead and do the homework. Make sure you fill out the tables so that you can get the answers correct in your homework assignment. And we'll talk to you soon. Message me if you have any questions.